this is where we were last time. What is the derivative of a position function? It is a velocity function. And what is the derivative of a velocity function? It is an acceleration function as well. All right, so good. So then last time we did the first part there where it was approximate a of 2. I'm not going to redo that one, but I do want to ask you guys a question. In that first part there, we really don't have a function that we could differentiate to get acceleration. So if you can't differentiate, that's fine. Just use the slope of the secant line. That's exactly right. So that's kind of that little saying we want to have. The other thing we want to do here is this other bullet point. It says, if v of t could be modeled by that v of t equals 0.66, et cetera, et cetera, et cetera, then use your calculator to find a of 8. Use your calculator to find a of 8. And so this is saying, okay, we've got this table. Somebody has done some kind of regression or whatever, and they've decided that the data in this table could easily be modeled by this function here. We're going to actually, find exactly a of 8 instead of approximating a of 2 like we did in the first part. So we can actually find the derivative, right? So use your calculator as an aid here. Let's go ahead and find a of t, and then we'll try to find a of 8 based on that.
Calculator can give you a slope at a point.
So remembering that to find the acceleration function from the velocity function, you need to differentiate velocity. I'm going to start off by just writing v prime of t equals, and let's go ahead and write down what that is. We're going to use the power rule a couple times, right? So what is the derivative of that first term?
1.32t.
1.32t. That is correct. Plus, what is the derivative of the second term?
13.2.
It is plus 13.2. And what is the derivative of that final term?
0.
0. So I'm not going to write plus 0. I'll just leave it alone. You guys have any questions so far? Okay, so if we want to find a of 8, we know that v prime of 8 is the same thing as a of 8. Derivative of velocity is acceleration. So it's just a matter of plugging in the 8 in the one spot there. So 1.32 times 8 plus 13.2. Did you guys take that all the way?
Yeah.
What'd you get, Lauren?
23.76.
23 point. Now, does it stop after the 7.6 or does it keep going?
It stops.
Just stops right there? Okay, so 23.76. The reason why I ask is one little thing that we want to start creating a habit of. If you're a science person and Drew, could you just talk a little quieter? Thanks. If you're a science person and you are used to sig figs, this might grate a little bit, but I don't think it's that big of a deal. Here in AP Calc, the standard way to handle decimals is 3 of them. Okay, so this one just stopped after 7.6, so you don't have to put 760. But if this thing kept on going 7.649.823 whatever, then after 3 decimals, you can either just round it off like normal, or you can just cut it off without rounding. But 3 decimals is the standard. Okay, so we'll try to create those habits throughout the year. So quizzing and testing, always go to that 3rd decimal beyond the decimal point, and or 3rd digit beyond the decimal point, and we should be good. It'll create a good habit for you. It's frustrating as a reader. Sometimes I'll read these answers, and it's like they clearly know what they're doing, and they get to the end and they put 10.98 instead of 10.981 or whatever. They lose a point. They lose the answer point. There are some mitigating things there where it doesn't totally kill you, but to lose a point on something like that is frustrating. So I try to get those good habits in you from the start. So anyway, there's that. You guys have any questions at all? Technically, we're done with everything. We've got 2 more examples that I think are worth our time. So let's go back up to those examples prior to this, like 10 and 11 or 11 and 12, whatever it is. Bless you. Number 11 says it gives you this g of x function, and that's the curvy function, right? It's a cubic. It's going to be curving all over the place, ups and downs and hills and valleys and all these things. And then it says find the equation of the tangent line. So you remember that graph we drew earlier? We had a curvy graph, and then we drew this line that approximated the graph right there. So we're going to be trying to find the equation of that tangent line when x is 2. Let's go ahead and do that now, then we'll do the other thing next. Okay, so let's go ahead and find the equation of the tangent line. And to help you with that, I want to remind you, what are the two things you got to have?
Find the derivative and the point plus slope.
Okay, so point and slope, but let's be specific here. We want to find the point of tangency, right? And the slope of the tangent line. So being specific like that, hopefully it'll give you some direction about where to start. Okay, so I'll let you guys give that a try. We've kind of done one like this before, and we'll do this again. And then the other one's a little bit different. So, guys, girls, let's check this out. What you've got here, maybe this is probably a good thing for me to just remind you of. What we have here is a cubic, right? And a cubic could look something like this. No guarantees that this is what it is. Well, let's just say this cubic looks something like this. It goes up, down, up. Something like that, right? Would that be a fair representation of some cubic?
Very fair.
Okay. So then, x is 2 is, like right about here, let's say. And so when we're talking about the graph or the equation of the tangent line, what we're really looking for is the equation of this. Oops, it was going to be a straight line. Let's try that again. Going with that right there. So there's the equation of that, or there's the representation of that tangent line. What we're trying to find is the equation of it, right? So let's remember this point right here is the point of tangency. And so that's one of the things we want, right? The other thing we want is the slope of the tangent line. So when you think about what those words actually mean, when I say find the slope of the tangent line, I'm really talking about what?
The prime.
The derivative. Yeah, all right. So specifically dy dx, or in this case, you could just say g prime. So I'm going to say, that's what I'm trying to find. I'm trying to find the slope of the tangent line. So I'm going to find g prime is equal to 9x squared minus 4x plus 1. Now, what does that mean? That's the slope of the tangent line where? Anywhere, right? That's the slope. Tangent line, any point we want to pick, we could just plug something in and we get the slope of the curve at that particular point. But we're only interested in when x is equal to 2. Okay, so I'm going to then plug in a 2. So g prime of 2 is equal to 9 times 2 squared minus 4 times 2 plus 1. And that's 36 minus, that's 29, right? So g prime of 2 is equal to 29. So this right here is the slope of the tangent line. And that is one key piece of information that we need. Does all that make sense to you guys? As I walked around, I saw a lot of really good stuff. Saw a lot of 29s, saw a lot of good process there. Are there any follow-up questions? Yeah, go ahead.
When it says find the equation of the tangent line when x equals 2, is that just the derivative that you found?
No, because the derivative is the slope of the tangent line.
So the equation is what you squared, like what you wrote in the square.
Nope. Nope.
That's the equation.
We haven't done it.
Yeah, we're definitely not done yet. Definitely not done yet. So I want to connect something with you, and this might seem a little silly, but let's connect this with what we're really talking about. If I could take you back in time a little bit, back to Algebra 1.
Go back in time.
Yeah, we're going back in time right now. Ready, set. There we go. So in Algebra 1 and Algebra 2 and pre-calc, yeah, it was surprisingly quiet to time travel, wasn't it? You'd think it'd be louder than that. No, but in all seriousness, in Algebra 1, you guys remember talking about y equals mx plus b?
I do remember that.
That's what we're talking about. We're talking about the equation of a line. Now, our line just happens to be a special line. It's called a tangent line. But let's not make it any more complicated than it is. All we're really doing is finding the equation of a line. So, let's, again, hey, listen. Just in the interest of connection, I want you to think about this. Like if I told one of my Algebra 1 students, hey, we know this line, and we know some things about the line. We know the line has a slope of 29, and it goes to the point, what is it, 217 or something like that? And I say, hey, let's find the equation of the line defined by those two things. They could do that. I'm asking you to do the same thing. So I think maybe if you're overcomplicating, you're thinking about, wow, a tangent line, what is that different? It's really no different. You have to actually figure out the slope yourself, right? I mean, so there's a lot more to it than that. But given a slope and given a point, just find the equation of the line. That makes sense? I think if we don't make connections to what you did in Algebra 2, we're doing you a disservice, right? If we don't make a connection with what you did in pre-calc or Algebra 1 or whatever, it's all the same stuff. So I'd like to break down the walls that make us feel like, oh, well, that was Algebra 2. That doesn't apply now. It really does apply, and it makes it easier if you can kind of see there's no walls. It's all just math.
No borders.
No borders. Yeah, we're open borders when it comes to math, right? If Algebra 2 wants to like creep into calculus a little bit and infiltrate calculus, we're good with that. Yeah, it's okay. It's okay.
Tearing down the communist bloc.
Oh, yeah, let's tear down that wall, right? There we go. Okay, so to your point, let's figure out the other piece of this puzzle. We need to have that point of tangency. So the way that we figure out the point of tangency is to realize, well, we have half of it, right? We know that it's 2 comma something. How do we find the y to go with that x?
You plug in the 2 to the, just have a g.
The g of x function, right? Yeah, g of x, yeah. So we're going to just write g of 2. And g of 2, of course, is equal to 3 times 2 cubed minus 2 times 2 squared plus 2 minus 1. And that ends up being 17, right?
Yeah.
Okay, you can do the arithmetic on your own. I'm sure you can all handle that. So what I've got here is I've got a point of tangency of 2 comma 17. And I have a point of tangency, or excuse me, a slope of the tangent line of 29. I like point slope form because it's easy. You can do slope intercept if you want. That's also just fine and not very difficult either. I'm going to write it as y minus 17 equals 29 parentheses x minus 2. And that right there is the equation of my tangent line. Yep, that's the equation. So, sorry?
You won't accept that?
Oh, 100%. 100%. I will love that. You could also, of course, you could also write this,
100% on the test, or just?
on that question at least. Y equals 29x minus 41. That is slope intercept form. That is also 100% correct. You would lose no points for that, right? And you could do all kinds of weird things, and they would be weird.
Plus 7x minus 7x.
Exactly, right? Here's something you could do. I'll erase this in a second. You could write y equals 29 parentheses x minus 2 plus 17. Didn't I just add 17 to both sides? Yeah. Now, is that any particular form? I don't think so. Doesn't really have a name, but isn't that a form of an equation of that tangent line? Yeah. It's okay. It's okay. Not a problem at all. Okay. Like I said before, it is super important that we understand what it is we're doing as opposed to just like, well, I plugged some stuff in, I got some numbers, and I have no earthly idea what it even means or what to do with it, but I got some numbers. Do you feel like you have a sense of what it is we are doing? I hope that's where we are. We're going to use this now, just a brief little application of it. Notice what it says following. It says, then use that tangent line that we just found to approximate g of 2.5.
Can you just find g of 2.5?
Now, yes, absolutely you could. What I'm trying to do here is I'm trying to build up to something that later on you're not going to be able to find g of 2.5, right? So I'm trying to go from like very simple to complex instead of the other way around. So let's talk about what this is actually saying. This says, use your tangent line to approximate the curve. Approximate, what does it mean?
Estimate.
Yeah, estimate. You're probably going to be off from the actual answer of g of 2.5, right? You're going to be off, but the word approximate or estimate, that's kind of inherent in that. You're probably going to be off by a little bit. And if you look at it, our point of tangency is 2. Let's say that 2.5 is like right about here. So if you look at the red line, that's going to be about that point on the red line. You can see it's going to be different from the orange curve, right? But remember, they didn't say find g of 2.5. They said approximate g of 2.5 using your tangent line. Does that make sense? So what do? We take our tangent line. And the tangent line, we just found that equation. And instead of plugging a 2.5 into g, we're going to plug a 2.5 into the tangent line for x. Yeah, exactly. So I'm going to take this right here, and I'm going to say something like this. So I'm going to try to use very good notation. Hopefully it'll be very clear to you. Check it out. I'm going to write y minus 17 equals 29 times 2.5 minus 2. So I'm plugging in x. I'm plugging 2.5 in for x, but I'm doing it with my line, not my curve, because what did it say for us to use? The line, right? So I'm going to use the line, just like it said for us to use. What follows is a little bit of arithmetic. 2.5 minus 2, of course, is 1/2. Half of 29 is 14.5. If I add 17, I think I'm going to get 31.5. So y equals 31.5. I think the next notation is really crucial. I'm going to say is approximately equal to g of 2.5. Does it make sense? So think about it. On the line, y equals 31.5, right? On the line. But that's not what the curve equals, is it? It's approximately what the curve equals. So that's why I put approximately equal to g of 2.5. Fully acknowledging g of 2.5 is not 31.5. I get it. I totally get it. But we are asked to use the tangent line to approximate the curve. We're trying to build from simple to complicated. That's what we're doing here.
For this approximation, so like if you're doing like something that needs to be like accurate, you probably do it a little bit like closer. Because it's off by like over 4.
So, the closer you are to the point of
Would
tangency,
you use a limit then?
you could think about it like that, but the further you get from your point of tangency, you're probably going to be further and further off from the actual true answer. We can certainly control our error as well. And so often it's simply a question of like how close do you want to be and how much time is that going to take? If you're okay with being off by like plus or minus 0.1, maybe it's going to be really easy to approximate. If you want to be within like 0.10 zeros and then a 1, maybe it's going to be more difficult. So we're just trying to build up this skill of approximation using a graph of a line and a curve as well as the function for both. Okay? Tiffany.
Why can't we, like, why would you just want the exact value?
Well, so in this case, duh, you're totally right.
Okay, I think.
Totally right. I say duh from my perspective, right? Why would I ask you to find something approximately when you could in just like 2 seconds find it exactly? Later on, you won't have the g of x function. You'll have something else. Or you'll just have a graph for it.
A graph?
So what I'm saying is, I'm trying to go from something that's very simple, and your question is totally natural, right? Like, why wouldn't I just find g of 2.5, right? Totally natural question. It makes perfect sense that you would ask that. I'm trying to go from something that's very familiar, like a cubic. Later on, we'll try to transfer this over to something that is way unfamiliar, maybe a piecewise function, or maybe just a graph that you don't even know what the equation is. We're still going to approximate it using a tangent line.
Okay.
That makes sense?
So if we don't
You good? So there might be situations where you don't even know what the function is, where it came from, because it's just based on data, right? So how can we still approximate it? Well, we could use a tangent line to do it.
Okay.
Believe it or not, you can actually use tangent curves to approximate things too. If you ever take Calc 2 or BC, you'll
Show
do
me a
that.
tangent curve.
Yeah, you'll have to take BC or Calc 2 to see that.
I'm not gonna.
All right, one last one to do, very differently, although it does look the same at first. It says, find the equation of the tangent line. We've seen that language. It's the third time we've seen that kind of language. Find the equation of the tangent line to the graph. It gives us f of x equals x to the fourth plus 2x squared. It's a quartic, right? Looks like an M or a W or something like that. This is where it goes a little bit weird. Aren't we used to it saying, at the point where x equals 2? That's not at all what it says, though. It says something totally different. It says, at the point where f prime of x equals 1. So here's what we're used to. We are used to getting the function. We're used to getting half of the point of tangency, right? X equals 2, like we just got in the last one. That's not what we got at all. Did I give you any of the point of tangency? What did I give you? I gave you the slope of the tangent line, didn't I? I said, hey, you know what? I'm going to give you the slope of the tangent line here. Your big job is going to be to find the point of tangency. So I want you guys to be a little bit of a problem solver here. You have all the tools you need. You could draw a graph of this if you want. That's what the calculator active part is. If you want to draw a graph of it a little bit and kind of see how these things are interacting. But at some point you're going to have to put pencil to paper and do a little bit of problem solving with this. Okay? So give it a shot, discuss. If you come up with a good idea, let me know. You basically say is, let's go ahead and find f prime. I think that's a good place to start. So f prime of x is equal to 4x cubed plus 4x. And then, what do we do with that? I've heard some really good ideas.
Set it equal to 1.
Set it equal to 1. That's exactly right. So if we set this equal to 1, doesn't that make perfect sense? Because the derivative, f prime, is the slope of the tangent line. And you're told the slope of the tangent line is 1, so they should be equal at the point of tangency, right? That's a great strategy. The only problem with this is going to be a nasty, nasty old equation to just like pop out the answer real quick. And so this is another place where I think the calculator being active is really key. What I would suggest we do here is write 4x cubed plus, that's supposed to be a cubed, let's try that again, plus 4x minus 1 is equal to 0. I'd suggest you graph it and use your zero finder. I heard a couple folks just saying, hey, how do we solve this equation? Some really good questions. I think that's a good place to go. So use that, and that should get you into a happier place. I think we're to a pretty good spot here. when you guys use the zero finder on your calculator for this, you guys get x equals 0.236?
Yes.
What is it? 2.237? Three decimals minimum, right? You can go above that. You can have like 7 decimals or whatever if you want, but you got to have at least 3.
On like a test?
Yeah.
Okay, so if we have less than 3, it's a -1.
Yep,
If we have more than 3, that's fine?
it's fine. Yep. Did you guys get 0.237 for your x value there? So that's the x value of the point of tangency, right?
Would y be 0?
Hey guys, Tiffany just asked a really good question. She said, would y be 0?
For that point.
Is it plugged?
So, Tiffany, listen. You found out, like we just graphed this right here.
Yes.
This is not the curve, right? That is the slope of the tangent line set equal to 1. So, like when you used the zero finder, you were simply finding where f prime was 1. It was not the x and the y coordinate for the point of tangency.
Okay,
That make sense?
kind of.
So, like if you graph this, the point 237 comma 0 is probably not on that graph.
Okay.
And that's the graph of the curve, right? So let's think this through. If we're going to be doing our equation of the tangent line, our final answer is going to look something like this. Y minus y1 equals m times x minus x1. Of those 3 things, this one right here, this one here, and this one here, how many of those 3 things do we have right now?
2.
We got 2 of them, don't we? We've got the m and the x. So let's fill those in. My m is what?
1.
Is 1. Yep, so 1 just goes right there. What is my x?
237.
Yep, 0.237, that thing we just found. So 0.237. The one thing we don't have is the y coordinate for the point of tangency. How is it that I could find the y coordinate?
You plug the x into the original.
Yep, plug it back into this. Okay, so it's going to be, I'll just do this off to the side here, I guess. So it'll be f of 0.2376 ... whatever you guys said. We're just going to plug that back into the original. So you're going to take it to the 4th and plus 2 times that squared, right? Did you guys come up with a y value? 0.115. Do you guys agree with that? Yes?
Yes.
Okay, awesome. So y1 is 0.115. Again, the calculator was active, so hopefully that made some of these crazy decimals be a little less crazy. Okay, so great job of problem solving. I should be able to give you different pieces of the puzzle, and you make them fit together instead of always giving you the same 2 or 3 pieces. I should be able to give you these other pieces, and you can be like, oh, well, let's just put them together this way, right? That's kind of the point of this question. Yeah, Drew?
How do we know that the slope is 1? Where?
Great question. Yeah, it says where f prime of x equals 1. So remember that f prime of x stands for the slope of the tangent line.
Okay.
So it's saying, hey, wherever the slope of the tangent line is 1, that's where we want to find this tangent line equation.
So we kind of found half of the point of tangent.
Well, with this, we found half of it.
Yeah, that's what I'm talking about.
Once we did this, we found the other half.
Okay.
Yep. Yep, yeah, setting, and that's because you were thinking is the y coordinate 0? It's obviously it's not.
Yeah.
We're only able to find the x coordinate from that, but because we had f of x, we could find the y coordinate with that
Okay.
as well. Yep.
So how, like, with the other one, where is it, right there? Let me look at it now.
Okay, yeah, go ahead. All right, so that concludes the notes right there for our quiz material. I did want to draw your guys' attention to a couple of other things. I would say that number 10 is one of those questions, we've all had them, where if you see it and you get it, it's like done, like in 2 seconds. If you don't see it and you don't get it, you could like sit there for 2 hours and you're going to be like, please help me, I don't get it, right? And so I'd love for you all to be in the camp of like 2 seconds, done, right? That's what my hope for you guys would be. So let's talk about this one. Wonderful question. Drew was talking about some stuff. He's like, hey, so you could try direct substitution. If you do, you get secant of x minus secant of x all over 0. And we all know that that's an issue, right? You can't divide by 0. So, wow, that's a problem. And so, yeah, our immediate impulse is to say does not exist because we really desperately want it to be that way. And I got to be honest with you, if you saw something like this on your quiz, I would almost rather you just like jump to DNE and like only waste 10 seconds and miss all the points, or 1 point actually. That should give something away. This is worth 1 point on a quiz. 1 point is all. I'd rather you just lose that point and only waste 10 seconds on it than like take 30 minutes. Waste 30 minutes and then miss some other ones because you wasted so much time and got frustrated. That's just like my own perspective. I'd want you to get it right. Here's how you get it right. You sit there and you think to yourself, wow, what I'm about to do is punishable by like math jail, federal math prison probably.
Everything by zero.
Watch. I do this laughingly, but I've seen this done, and we're all gonna just say none of you would ever do this. So
So just to clarify, this is wrong.
This is the bad example?
this is horrible. Horrible.
Oh, see, I thought it was-
We're all just gonna say none of you would ever be tempted to do something like this. Oh, look, the H's. I'm just left with secant. That is punishable by like 20 years in math prison. That is so wrong on many levels.
Except if you're ESPN, then they love that problem.
Yeah, create some. Oh, there you go. Yes, and it's controversial, right? So people would pay attention. So here's so like that's terrible math, right? You can't do that either.
I'll be mad.
Most of the time, now think about this. Most of the time, when you get the zero in the denominator, can't we usually do like some factoring and canceling, and voila, there we go, it's done. That usually works a lot. That's not going to work here. Here's what you need to do. Here's the little twist to this. You need to look at this and recognize it for what it is. It is the definition of the derivative. So here is step one. This is all in your brain. Step one, recognize that that is the def of deriv. That is the definition of the derivative. And just to clarify, limit as h goes to 0 of f of x plus h minus f of x all over h. We need to recognize that that is the definition of the derivative. That's step one. That might be easy, that might be tough, but that's where we want to get to. Definition of the derivative. Step number two. You have to ask yourself a question. Once you say, yes, I made it, I made the connection, it's the definition of the derivative, you got to ask yourself the question, of what? What is it the derivative of? It is. If you notice, like you've got f of x right here, you've got f of x plus h. Doesn't that match secant of x plus h, secant of x? And so when you say derivative of what, you'd have to say that is the derivative of secant of x. And then your final step, hopefully the happiest one of all, you say, and that is what? You have some remembering to do. Secant x, tangent x. There you go. Secant of x, tangent of x. So guys, it's worth 1 point. Because literally, imagine a math teacher saying this, the vast majority of the work is done between your ears. Right? You're going to be like, oh, I recognize that. It's the derivative of something. It's the derivative of what? It's derivative of secant, which I remember from learning before that that's secant x times tangent of x. Austin.
How is it secant of x, tangent of x?
I'd be happy to prove that to you.
That's the derivative of secant.
So here's how you do it. If you wanted to do the derivative of secant of x,
Let me write these down.
here's what you would do. If you wanted to prove this to yourself, so ddx is like an operator, like a plus sign is saying add these two things together. ddx is saying do the derivative of this thing. Right? So derivative of secant of x, I would transform this into ddx of 1 over cosine of x into a nice familiar form. And I do know the derivative of cosine, don't I? But it's a fraction, and so I have to use what? Quotient rule. So I'm going to say low d high, which would just be, what's the derivative of 1? 0. So low d high minus high d low. So that would be negative sine over the square of what's below. So I'm going to just write it as cosine x, because that's what cosine squared is. So of course, cosine x times 0 just cancels out to be 0. and a negative times a negative is a positive, so I end up with sine over cosine cosine. And here is where your trig identities would come into play. What is sine over cosine?
Tan.
Tangent. What is 1 over cosine? Secant, so it would be tangent times secant. So you could do that with all of those trig functions, you know, like cosecant or cotangent or tangent, to see their derivatives. You can prove all of those simply by using a little bit of trig identity and a quotient rule.
That is
So,
amazing.
oh, there's more. There's
We
more to
have
be done.
prove those in proofs.
It works out right. There's a reason. It's not just, hey, some smart dude came up with this. You know, there's a smart lady up in a room and she invented this. You can actually prove it. Right. So, Austin, does that help? Okay, cool. Guys, we still got time. Did that make sense to you guys? You all were saying, hey, maybe we should talk about 10. So, there's a pretty limited number of things I could ask you about with a question like number 10. Right now, it's kind of trig functions. That's it. So, be ready. I would say